Hi guys, on this video I'm going to talk about how scientists, how physicists represent physical phenomena. So this is a document that I have on linked on my main resources of my physics resources because we're going to use it all year long. And it's a good guide to think about what I have to include in things like lab reports, whiteboard presentations, or even mini lab reports. So I also have open here the lab report writing folder, and I'm going to talk about that as well after I go through the list of how to represent physical phenomena. So there's different ways of thinking about problems in physics and the things that happen. One thing that we can do to simulate a real life problem is actually model that problem, actually doing a lab on it, whether it's a virtual lab or a lab that you write down or a lab that you do it yourself physically. That is modeling. Another thing that you can do is sketch out that in your mind. So when Einstein figured out the theory of relativity, general relativity, there was no way to actually do an experiment. He actually proved the entire theory mathematically and through models of thought experiments. So that's kind of like how physicists think of problems sometimes. And you're definitely going to need to develop that skill of thinking in your mind's eye about the problem. Another way of representing is through words. And on procedure sections, that's pretty much what you're doing. You're describing everything you have to do the lab, and you do so in a way that anyone could replicate it. So that's the word part of representing your physical phenomena. In a lab report, the results section also describes what happened with words. That would be descriptions of everything that happened, including errors, averages, trials, statistics, things like that, right? But this is more, I mean, the words description of the statistics, not the numbers, right? So even if you do calculations, you still want to describe with words. Now, if you're doing a presentation, you might do that verbally, but it's still using words to describe these things. The conclusion section of a lab or a presentation about a lab also includes words, right? So for experiments, it's a conclusion of whether or not what you expected was rejected or not, right? So was your hypothesis rejected or not? Then you have to explain why the results happened the way they did. You have to explain things that you did wrong and any limitations that you've had, and how you could have fixed up those limitations or reduced the errors that you had in the next time you do it. You can also talk about ideas for follow-up examinations. What could you do to study this further? How could you apply this in real life? And why is it important for science or society? And any other general things you learn from the lab. So if you're doing a lab report, if you're doing a presentation in class, or even a mini lab report, you definitely want to include words on your descriptions of what happened. And this is how and why you will include these words. A good representation of physical phenomena will also include pictures. Pictures are going to be included, or should be included, in procedures sections, where you write clear diagrams of their setup. You should also include pictures on your results sections, where you diagram the before, the during, and the after of your experiment. You could also do that with other types of visuals, which include videos or pictures or actual physical pictures that you took of the setup. And I strongly encourage people that are doing lab reports or labs to take pictures while they're doing the lab so they can include on their reports or even videos. So visual representations of the physical phenomena are very important, and you should include them in your presentations in whatever format I ask you to do. Another good thing that any representation of physical phenomena should have is data. You need numbers. You need to correct numbers as they were collected in a data chart. You need to make averages in multiple trials, right? Hopefully that is the case. You also should include proper units for any number that has units. Otherwise, we don't know what those numbers mean. Numbers should be collected with appropriate number of significant figures so that you can correctly represent the level of precision that you've had throughout your experiment. And all of that should be organized in tables with columns and rows titled, units listed at least in the title of the rows or columns, and labels for all the numbers so that we can know what they mean. You should also include on your representations of the physical phenomena that you observed maths or formulas that you've used to compute results. Calculations and formulas are definitely important for any science class that you're doing. The last thing should be graphs. You should always try to represent your data in a meaningful way that someone can quickly look at and kind of know what it is. And that's what graphs are for. Data tables are great. Mathematics are great. Words are great. Pictures are awesome. But graphs is how us in science quickly communicate to others the patterns that we see in our data. I'm going to make a special video about that so you have some visuals for to go along with the words that I'm trying to explain to you. So see you there.